Hello and welcome to Amit's Tech Sessions. I'm Amit and I'm a software architect. Software architecture and platform architecture are two different aspects in modern technology world. I've seen people talking that software architecture is different from platform architecture. Yes, they are two different things, but my view is that they rely on each other very much. A software cannot run without a platform, and platform is not useful if a software is not running on it. Kubernetes is one of the platform for running software, and in this video, I will talk about what role Kubernetes plays in developing the modern software architecture. We will do a quick introduction to Kubernetes. This is for the folks who are not familiar with Kubernetes. Kubernetes is a container orchestration platform and it is open source to use. There is no license of using Kubernetes. It was initially developed at Google to solve the challenges which are related to managing the containers at large scale. Kubernetes was then publicly announced in 2014 by Google, and then it was donated to the Cloud Native Computing Foundation, or CNCF. CNCF was established by the Linux Foundation to nurture cloud native technologies. Kubernetes became CNCF's first project, and as of today, Kubernetes is the de facto standard for container orchestration. It provides automated deployment, scaling, and management of containerized applications. Most of the cloud providers such as AWS, GCP, Azure, they all provide their managed Kubernetes offering to the industry so that industry can remove that undifferentiated heavy lifting of managing the Kubernetes themselves. In a nutshell, Kubernetes solves the problem of managing the containers at scale. Let's now talk about traditional software architecture and modern software architecture. So, traditional software architecture often relies on the monolithic structure where all those components are tightly integrated, such as business logic, presentation layer, application layer, database tier, all are tied together in a single component. And it makes it difficult to scale, it makes it rigid, it makes it prone to inefficiencies. And in contrast, today's modern software architecture embraces the modularity, which comes with microservices and containers. Microservices as containers, they enable dynamic scaling, high availability, and also a seamless integration with cloud native environments. Cloud native infrastructure is very popular in modern architecture today, and we'll discuss how Kubernetes supports cloud native architecture later in this video. I'll now walk through the core features of Kubernetes. The first one is container orchestration, and that is the primary core feature of Kubernetes. That is why Kubernetes was actually built. It allows automated deployment of containers and then scales the containers based on the workload demand, parameters such as CPU, memory, traffic, etc. Second feature of Kubernetes is load balancing. When you deploy an application which is highly available, you need to load balance that application to route the traffic to appropriate nodes, and then load balancer distribution should also be efficient. And Kubernetes provides that capability itself. The third one is self-healing. If any of the containers are failing in the Kubernetes cluster, Kubernetes auto-heals them. It either restarts those containers or replaces the failed containers. So next one is scalability. With Kubernetes, you can implement both horizontal and vertical scaling. Kubernetes provides horizontal pod autoscaler, which scales out the pods based on the defined threshold on CPU, memory, or any other parameters. There is also a tool called Carpenter, which is used to efficiently scale out the nodes based on the workload demand. So you can define a threshold, and then on that threshold, Carpenter will add new nodes to your cluster or will reduce the number of nodes based on the your setup, based on your demand. or setup. And the next one is declarative configuration. So in order to deploy your application on Kubernetes cluster, you have to write Kubernetes manifest files, which are generally written in YAML format. So all your application configuration is defined in YAML file, and then it is applied to the Kubernetes cluster. So now let's see how Kubernetes and modern architecture, they tie up together. One of the popular pattern of modern software architecture is microservices. Microservices are set of independent autonomous services, each providing a specific functionality and are independently deployable. With Kubernetes, you can easily run microservices. Kubernetes provides containers and container networking capabilities, which allow the businesses to run their services in an isolated manner and also in an independent manner. CI/CD pipelines are common in modern software architecture, and they are one of the foundation of DevOps. With Kubernetes, you can build a full-fledged CI/CD workflow to deploy your applications on Kubernetes. Modern software architecture, they often rely on cloud-native development and cloud-native tooling and technologies. Kubernetes has a great support for building cloud-native applications. Kubernetes is available as managed offering by all popular cloud providers such as AWS, Azure, and GCP. Kubernetes also supports hybrid cloud and multi-cloud deployments. Dynamic scaling. So modern software applications, they require dynamic scaling based on the demand. Software applications want to scale based on their traffic, their CPU, or their memory, or any other criteria. Right? Kubernetes supports dynamic scaling of the workloads. It provides capabilities such as pod autoscalers, cluster autoscaler, Carpenter, etc. Let's look at this simple diagram on how you can have microservices running in Kubernetes. So we have a Kubernetes cluster here, and there is a worker node as part of this Kubernetes cluster. Worker node is just a virtual machine. In AWS, it can be an EC2 instance. In other cloud providers, it can be their virtual machine offering. And we have two microservices running, Service 1 and Service 2. Both are containerized, and they are deployed as Kubernetes pods in the worker node. This is just a simple example, hence I've used only one worker node. However, in reality or in practicality, these pods can be spun up on multiple worker nodes. So this architecture provides an isolation of services. Both are independent deployable units. So both are microservices and can be independently scaled and can be independently deployed. Hence, Kubernetes is a great choice if you want to develop and deploy microservices. As we discussed earlier, Kubernetes greatly supports cloud-native architectures. So most popular cloud providers such as AWS, Azure, and GCP, they have their Kubernetes offering, which is widely used by the industry. Kubernetes supports and enhances the portability by providing a consistent runtime environment. For example, if you have deployed the application in dev or in development environment, you would get similar environment in the production as well, so that debugging and troubleshooting becomes a bit easier for the developers or the platform engineers. Cloud native architecture do need CI/CD pipelines to deploy the applications, and Kubernetes has seamless integration with CI/CD pipelines of different types, such as Jenkins, GoCD, CloudBees, Argo CD, and many more. Hence, Kubernetes is a great choice if you want to develop and deploy the cloud-native applications. Let's now understand some of the benefits of Kubernetes in the software architecture. First one is portability. With Kubernetes, you can have unified environments across development and production. As I said earlier, this unified environment provides the consistency in reproducing any issues which you may have in production or in development or in any other environments. Second one is resilience. So Kubernetes provides self-healing and fault tolerance capabilities. If any containers are failed, Kubernetes would restart or replace those containers. And these self-healing and fault tolerance can lead to a high availability of your application. Third one is efficiency. As Kubernetes has dynamic scaling features, it leads to that optimized resources, which ultimately leads to the optimized cost. Kubernetes is very flexible. You can deploy various types of workloads on Kubernetes, such as stateless, stateful, batch jobs, even AI/ML applications, artificial intelligence or machine learning applications can be deployed on Kubernetes clusters. Kubernetes is very extensible and it has integrations with a wide variety of tooling. For example, it can integrate with various observability tools or monitoring tools such as Datadog, X-Ray, Laceworks, and many others. Last but not the least is its community and ecosystem. Kubernetes has large community of people and it is open source community where people can learn from each other free of cost. The surrounding ecosystem of the wide variety of technologies, it makes it an attractive option to choose for the modern software architecture. While there are various benefits of using Kubernetes, there are several challenges and considerations as well. The first one is complexity. Kubernetes has a deep learning curve. If you want to set up and manage your Kubernetes cluster, you need to learn that, and it's not straightforward and easy. And if you learn that, then there are a lot of jobs available in the market, which are titled as Kubernetes engineer, and they just look for the Kubernetes skills, specifically the Kubernetes administration skills. The second one is the resource management, and that is one of the consideration which we need to take if you are installing the Kubernetes or deploying workloads on Kubernetes. We need to consider that allocation is optimized well, and dynamic scaling can help with that. Over allocation can lead to unnecessary costs. Another consideration is security. Security is backbone for any application or a platform. While we deploy our applications on Kubernetes, you need to ensure that all aspects of security are covered, such as network security, identity security, runtime security, and all other areas as well, authentication, authorization, etc. Running and managing a Kubernetes cluster can become an overhead for many organizations. So it has a lot of operational overhead if you are running and managing a Kubernetes cluster. And that's the reason most cloud providers provide a managed Kubernetes offering, and that is widely being used in the industry. In summary, Kubernetes is a foundation tool for the modern software architecture. It provides you the scalability, the resilience, the efficiency in all the containerized applications running. So it is a great fit for modern software architecture. And organizations can future-proof their applications by embracing Kubernetes. If you're not using Kubernetes today, you should use Kubernetes for large-scale applications or large-scale containers. My personal view is that if you are running just tens of containers or few containers, you don't necessarily need to use Kubernetes. There are other simpler solutions available than Kubernetes. But if you're running a large number of containers in your business or in your business unit or in your organization overall, you should leverage Kubernetes to help with management of those containers at such large scale. So that's all from this video. I hope that was useful. If you would like to connect with me on LinkedIn, there is QR code on the left. I also write some blogs and articles on Medium. So if you want to follow me on Medium, there is the QR code on the right. Thanks very much. I'll see you in the next session.